Oops. Let me start recording now. Yeah. We missed one question. Okay, so second question. The test statistic of z equals negative 3.39 is obtained when testing the claim that p equals 3 over 8. So this question is similar with the previous question, but of course it's different, right? The details are different. Yeah. Our original claim is p equals 3 over 8. So based on the original claim, we can figure out the null and the alternative. Yeah, the null is equal. So in this case, our original claim is the same with the null. Then how do we find the alternative? Yeah, when you read the question, there's nothing say about like a bigger than or less than, then our alternative is supposed to be p not equal to, okay? Not equal to. Yeah, so the alternative is p is not equal to 3 over 8. So this is a two-tailed test. Two-tailed test. Two-tailed z-test. Our significance level alpha equals 5% or 0.05. So we have we have critical regions in both tails. Yeah, half alpha here, half alpha here, right? Yeah. So here we have 0.025. Here also is 0.025. We got a 0.025 from the alpha. Divide alpha by 2, you would have a 0.025. That's the area of the critical region in each tail. Yeah, we have two tails because it's a two-tail test. And we are going to find the critical values. Yeah, this time we're going to have two values, all right? Yeah. The question would tell you like use a comma to separate, right? Yeah, something like that. All right, so this is going to be negative z alpha over 2. This is going to be positive z alpha over 2. Knowing z curve is symmetric with respect to the origin, 0, right? So we really only need to figure out the -1, the critical value in the left tail, and then change the sign to get a positive critical value. Is that clear? Yeah, we only need to get one of them, and then we know the other because they are opposites. Yeah, they are opposites. OPP, OSIT. We do use sometimes once in a while we use the knowledge from algebra, right? Yeah, like the very beginning we use a percent. Yeah, those are formulas from percentage, and now we use the opposites. Okay, so let's go to calculator. Turn on the calculator, and then we go to second verse. Normal, inverse normal again, right? Let me write down the name of the function we are going to apply. Inverse normal again, because we are looking for the critical value. Yeah, critical value is a value, so inverse normal. Area, this time not a 0.05 anymore, okay, is half of it, 0.025. By the way, if you have trouble to even calculate that, all you need to do is do 0.05. Yeah, that is the given significance level, and then divided by 2. Yeah, right in the calculator. The calculator will calculate everything for you. Okay, and then mu 0 sigma equals 1. Paste. Yeah, guys, what do you have? The -1, I got. This one is a negative 1.95. Okay, actually, I have the rounding rule, copy paste here. Round to 2 decimal places as needed. Use a comma to separate answers as needed. Yeah, so I don't have to write all those digits. I can just round it right now. Yeah, -1.96, right? It's actually a very common used critical value. Then the positive one would be positive 1.96. So when you enter the answer, you would do -1.96, comma 1.96, because you have two critical values in this case The test is a two-tailed test, two-tailed z-test. Awesome, very good. Yeah, very good, very good. Yeah, thank you, Courtney and Kelly. Perfect. Yeah, we have two, all right? Yeah, we have two. Very good. Is Miranda here today? Oh no, she's not even here. I'm talking about her questions now. Okay, well, so that's second. Oh, okay, we are not done yet. Part B, should we reject no or should we fail to reject no? Well, let's see where is this test statistic fall, right? Yeah, the test statistic z equals negative 3.39. It fall, change a different color, change a black color, yeah. It fall to the left, yeah, negative 3.39. Yeah, knowing when you have two negative numbers, the one with a bigger absolute value is smaller. The one with a smaller absolute value is bigger because it's closer to zero. So negative 3.39 is further away from zero. So it is to the left of the critical value. So the test statistic fall in the critical region. So by the critical value method, we know we should reject. Okay, yeah, reject. Because a rare event happened, yeah, based on the sample you got. Yeah, you only have one sample, turns out the sample, the test statistic fall in the critical region, that means a rare event occurs. Yeah. Then that means the assumption, what assumption? All the process is based on the assumption. What assumption? The no is true. Yeah, so that means the assumption is false. We have to reject it now. Any question about number 2? Any question about number 2? Yeah, let me fix the writing. This is 0.025. This is 0.025. And I need to make this smaller, thinner. You can see the writing better. Are we good with this one? Similar with the first one, but this is a two-tail. Hello? Okay. Yes means clear, right? Okay. All right. Next. If you ever have any questions, just feel free to tell me, okay? Yeah. Most of the time, only Kelly communicate with me. All you guys, all other, you just keep silence. Okay. So this one, the test statistic z equals 1.54 is obtained when testing the claim p is bigger than 0.2. Okay. Original claim is p bigger than 0.2. So our no is p equals 0.2. Our alternative is p bigger than 0.2. Yeah, I don't mind to keep repeating the same thing. Yeah, the original claim must be the same with either the no or the alternative hypothesis. Has to be the same with one of them. Yeah, since the no is equal, so in this case, the original claim has to be the same with the alternative. And then we determine which tail, yeah, what type of test based on the alternative, So the alternative tells us this is a right tail test, right tail z test because of proportion, right? Yeah, right tail z test. Then our critical region gonna be in the right tail, z sub alpha. Okay, alpha is 0.1. This is part C. What is part A say? Identify the hypothesis test as being two-tailed, left-tailed, or right-tailed. Okay, we got that figured out. It's right-tailed. Part B, find the p-value. Okay, well, let me fix this part a little bit. Yeah, we do not need a critical region yet. Yeah, if we do part B to find p-value, yeah, we need a test statistic. Yeah. Test statistic Z equals 1.54. What color? I'm gonna use blue color. Yeah. Let's say Z equals here. Z equals 1.54. All right. And our p-value is the probability that Z is bigger than 1.54. Yeah. The p-value actually is the area of the region to the right of the test statistic. Yeah, knowing this is not critical value, okay? Yeah, difference is critical value always have a subscript, either Z sub alpha or sometimes Z sub alpha over 2. Yeah, but test statistic doesn't have any subscript. All right, so this time we are going to find the p-value, which is the area of the region shaded in blue, the region to the right of the test statistic. Is right here, right? It's right here. Okay, then what function we are going to apply in the calculator? We are looking for the area, right? Yeah, we are looking for probability. So not inverse normal anymore. It's gonna be normal CDF. Okay, we never use a PDF, always a CDF, cumulative. C here means cumulative. So let's go to second verse. Normal CDF. The region, yeah, look at the shaded blue region. Start from, yeah, we always look at it from the left to the right. Yeah, the region is bounded from the left by 1.54. So your lower, yeah, I'd better write it down. Your lower is 1.54. Your upper is gonna be E99, the past infinity, and mu of course 0, sigma is 1, and you paste, right? P-A-S-T-E. Okay, yeah, that's the key information that we need to enter in the calculator. Yeah, lower is 1.54, upper is double E. At this point, you should know how to find the double E. Let's see, do we have any questions? You probably have the answer, right? Yeah, let me figure out my answer and then compare with yours. I got 0.0. Let's see how do we round it, guys. Round it to 3 decimal places is needed. Okay, yeah, round it to 3 decimal places as needed. So 0.062. Yeah, since it's 0.06178 and so on. So round it up 0.062. 0.062. Yeah, that's the p-value. P-value 0.062. Awesome. Thank you, Dustin. Yeah, thank you, Courtney. Yeah, correct me if I announce your name wrong, okay? Yeah, thank you, Melinda. Yeah, okay, that's the from before. Awesome, guys. So that's part B. Yeah, p-value. Part C, find. Oh, okay. Use it. Okay, so this one is about the p-value method. We don't really need a critical value. Yeah. Use a significance level 10%. That's very high. Should we reject no or should we fail to reject no? Okay, we're going to compare the p-value we got with the significance level. P-value is low, right? Yeah, p-value is low, no must go, so we reject. All the 3 questions are reject, right? Yeah. So it's very important to remember that if a p-value is low, lower than the significance level, then no must go. Yeah, so must go, so we're gonna reject no. So that's the answer. All right. All right, good with number 3.
Question.
Yes.
So if we reject it, does that mean we're if we reject no, we're accepting the original claim then?
Oh, that's a very good question. Yeah. So we reject no in this case. When we reject no, we say we have sufficient evidence to support the alternative, which is the original claim. Okay, let me show you the table. I'm going to include this table in a formula sheet. Yeah, so in this case, our original claim the same with the alternative, and we decide to reject the no. Then what's the formal conclusion about the original claim? We say there's sufficient evidence to support the original claim. Yeah, when you take the test, if you are required to make that formal decision about the original claim, look at the chart, look at this table, you'll be fine. All right. Of course, understanding it is important. Yeah. Since you reject no, of course, you reject no, then you support the other one, right? Yeah. Did I answer your question? Yeah, I will definitely include that chart. Yeah. Okay, very good. Thank you, Melinda. Let's move to
For
the
for that sheet, looking at it, would it be possible to add it to Blackboard so that way, like, we could print it as we're continuing to work on problems and stuff, just to make sure that we're used to referencing it from that sheet and not our own formulas and stuff?
You are talking about the formula that
The thing that you have right up there on the screen right now, like, would it be possible to just add that Word file to Blackboard?
You mean post it?
Yes.
I would like the testing center printed out for you instead of you bring it with you there. You know what I'm saying?
But yeah, no, and that's great for the testing center to do it too, but it'd be nice to have it as well, just to make sure that we're used to, like, finding the formulas on it.
Okay. Okay. Why don't you just take a screenshot? But I understand you. I'll post it.
Okay.
All right.
Thank you.
Yeah. I just added it today, like right before the class, because some of you emailed me this afternoon. I just look at the more requests, more formulas requested, so I add them here. And no problem. Yeah. Let's go back the questions. Yeah. Let's see any questions here. Oh, no problem. Okay, so here. Number 4. The test statistic is z equals 1.22. Original claim. Okay, original claim is given. P not equal to 0.544. No alternative. Yeah, remember the no always just equal to. Then the original claim would be the alternative, right? P not equal to 0.544. So what kind of test this is? Two-tailed test, right? Yeah, two-tailed z-test. Two-tailed z-test. Yeah, you know it's a z-test because z here, right? And yeah, so there's no problem. Definitely is a z-test. Okay, two-tailed. So yeah, let's see what's the question. Part A, identify the hypothesis test and as being two-tailed, or we got it as two-tailed, right? Find the p-value. Okay, so since the test is two-tailed, this is a very good question, and the test statistic fall in the right tail. Let's say this is a z, which equal to 1.22. Then our p-value is going to be 2 times the probability of z is bigger than 1.22. Okay, yeah, the area of this region, I'm writing what's the color I'm using? Green color, yeah, blue color, yeah. So this is only half of the p-value, okay? Yeah, we are going to find this area. We are going to find the area of this region and then double it to find a p-value for this question, for this test, because it's two-tailed test. All right, it's two-tailed test. Let me show you the formula. I think Kelly asked about to include the type 1, type 2 error. Who asked that? Yeah, p-value formula, right? Maybe it's Kelly or Melinda. Yeah. So you have this here, guys. You have this here. So as you can see, for p-value, you have a two-tail. You have for the p-value of a two-tail test, you must double. Okay. Yeah. Multiply 2. Double the area in one tail beyond the area, like in one tail beyond the test statistic. Okay, yeah, very important. Many people forget that, so I'm emphasizing it. Please don't forget. Well, let's see what's the area of this region. Since we are looking for area, then the function we are going to apply in a calculator is going to be normal CDF. All right, normal CDF. Let's go there. Turn on the calculator. Second bars, normal CDF. Lower, let me write it down, the key thing. Lower is 1.22. Upper is double E99. Yeah, mu 0, sigma is 1, paste, right? Yeah, let me enter the answer. Yeah, 1.22. And the upper is E double infinity. Yeah. And have this value, and I'm going to multiply that value by 2. Okay, yeah, don't forget that. Multiply the value by 2, and then I'm going to round it to 3 decimal places. My p-value is going to be 0.222. 4 is lower than 5, I'll round it down. Yeah, my p-value is 0.222. Let's see if you have the same thing. Oops. Awesome. Oh, it's 2 to 2 is, yeah, it's 2 to 2 because 4 is less than 5, so we have to round it down. Awesome, very good, guys. Yeah, be very, very careful with the rounding, okay? Yeah. Seriously, if you enter 2 to 3, it's really a shame that you lose the point of the question and it being so close. It's just a rounding problem. And that's the p-value. Proceed using a significance level 10% to decide on rejecting or failing to reject a no. Okay, so our test statistic is 10%, yeah, 0.1. Our p-value is pretty high, yeah, 22%. So this time p-value is high, no must fly. So we decide to fail to reject the no, okay? Fail to reject no. Yeah, in this case, we fail to reject no. All right? Is this clear, everybody? Four questions. I think the 4 questions are very good selected because they cover left tail, right tail, two tail, and the p-value method and the critical value method. They are good questions. Well, if you don't see anything, I'm going to proceed, okay? Yeah, so we have a Kelly asked this question. So the first question is actually very similar with one of the questions we just went over. Yeah, the test statistic. Let me double check everything is fine. I'm recording, I'm not muted. Okay, awesome. The test statistic Z is 0.69 obtained when testing claim. Okay, original claim, use black, is P bigger than 0.8. So our no is going to be P equals 0.8. Our alternative is P bigger than 0.8. So this is the right tail. Okay, you can see my board is getting weird. I didn't mean to have writing like this. Right tail. Tail test, right tail Z test, okay? Let's see what's the question here. Part A, right-tailed. Okay. Part B, p-value. Well, we can use the test statistic to find the p-value, right? Yeah, since it's a one tail, and we don't have to double it. Yeah, we're gonna figure out where is the test statistic. The test statistic is a 0.69 z equals. So the area of the region to the right of the test statistic, that's gonna be the p-value. All right, yeah, we at least have done that twice earlier. So the function we are going to apply is normal CDF. Normal CDF. The lower is going to be 0.69. The upper is going to be past infinity. Okay, yeah, past infinity. All right, let's see. Let me get my calculator. Second verse, normal CDF, lower 0.69, upper double E 99, 0, 1, paste. Okay, I got my p-value. What is your p-value? How do we round it? Round it to 3 decimal places. So the decimal I got is 0.2450970230203. Yeah, since the digit to the right of 5 is 0, we round it down. Yeah, the answer is 0.245. 0.245. Awesome. Very good. Very good. Perfect. And the multiple choice question, part C. Choose the correct conclusion. Yeah. So if we compare our p-value with our significance level, p-value is very high. Yeah, 20, almost 25%, a quarter. Oh my gosh. So it's a lot bigger than the alpha. So fly. P-value is high. No must fly. Fly means you fail to reject no. So fail to reject. Yeah. Fail to reject. Fail to reject. Right. Yeah, these two out. Yeah. And then what's the formal conclusion? You fail to reject. Your original claim is bigger than. So you fail to reject no. That means it's possible the no is right. So you do not have sufficient evidence to support your original claim. There isn't sufficient evidence to support the original claim, right? And also you can look at my chart here, right? Yeah, when the original claim equals a no, fail to reject, and you say there's no sufficient evidence to support the original claim. Okay? So if it's fail to reject, will it always the not sufficient? Not always. We have 4 cases. There's another case is also fail to reject no, but the original claim is the same with the no. Of course, the conclusion would be different, right? Yeah, when your original claim is the same with the no and you fail to reject no, then you would say, I have no sufficient evidence to warrant the rejection of the original claim. It's different. So you, in the chart, you have multiple columns. You have to look at all those columns to make the decision. Did I answer your question? Okay, awesome. Very good. Next question. An IQ test is designed so that the mean is 100, standard deviation is 12 for the population of normal adults. Yeah, let me take my notes. So I have mu equals 100, sigma equals 12 for the population. Population is normal. Find the sample size necessary to estimate the mean IQ score of statistics students such that it can be set with, okay, so this is confidence interval question. we're looking for the sample size necessary to estimate the mean. The mean, okay. Well, this is E actually, right? This is E. That the sample mean is within 3 IQ points of the true mean. So our E margin of error is 3. Assume sigma is 12 and determine the required sample size using technology, then determine if this is a reasonable sample size for a real world calculation. Okay. The formula is included in the formula sheet. I just did that earlier, right? Sample size. Find the sample size necessary to estimate the population mean is right here, the last one. Okay, let's see how do we use this formula to find the minimum sample size enough for us to apply the confidence interval estimate. Let's plug in. Okay, we have to find a z sub alpha over 2. That's very important. Okay, what is alpha? We know 1 minus alpha is 99%. Yeah, this part probably is the challenging part because the z sub alpha over 2 is not given. We have to figure it out ourselves. How do we figure it out? We start from the confidence level that is given. 1 minus alpha is the confidence level. 1 minus alpha is 99%. So you would know alpha is 1%. Right? Because they are complement. Yeah. And then alpha over 2, half of it would be 0.5%. As a decimal would be 0.005. 0.05. And we are looking for z sub alpha over 2. And that reminds you, that's a z distribution. Standard normal. Standard normal distribution. Okay? Excuse me. And the z sub alpha over 2 is right here. Okay, it's right here in the right tail. And the area to the right of the z sub alpha over 2 is 0.005. I have a question. If the shaded region, green region has area 0.005, what is the area of the blank region? What's the area of the blank region? Yeah, anyone can answer me my question? Awesome, exactly 1 minus 0.005. Exactly 1 minus, because the area of the region below the density curve must be 100%, right? Yeah. So subtract 0.5% from 100%, we have 99.5%. So 0.995. Okay, 0.995. Okay, we need that when we apply the inverse normal function to find the z alpha over 2. Okay, yeah. Let's go there. Turn on the calculator. And the second verse, inverse normal. The area to the left, all right, yeah, very important, is to the left of the z-score. You have to modify if the value isn't given directly. So it's a 0.995. Keep mu 0, sigma 1, and paste. My value, my critical value, is 2.5758. Let's see how do we round it. Round up. Okay. Okay, so z sub alpha over 2 is not the final answer we are going to enter to the system, right? So I would recommend you keep as precise as possible. So 2.5758 29303. Yeah, you have those digits available, the precision available. Now why not just use it, right? In case that you round it and you end up with a very similar value, but not the value the system want. Yeah, we don't want that happen. So keep the critical value as precise as possible. Okay. Yeah. So we have a 2.575829303. Yeah. And then alpha is 12, so we're going to multiply 12 all over e is 3, and then take the power of 2. Yeah, so this is what I would do. I already have this value, right? I already have that value. I'm going to just multiply by 4, because when you multiply by 12 and then divide by 3, 12 over 3 is 4, is just multiply by 4, right? Yeah, I multiply by 4. Hey, I have the value, critical value on my calculator already. I don't have to enter again. It's just multiply by 4. You would see answer times 4. And then enter. Right now, I'm looking at 10.30331721. That's the value of the base of the square. All right. And then you raise to power 2. Yeah, this is how you raise to power 2. This notation. Find this key, okay, and then 2. Raise to power 2. Yeah, it's right above the division symbol, division button, raised to power 2. And so you have answer square. And I got a 106.15. So is 106.15. Yeah, that's enough for me to round to the nearest whole number. Yeah, again, super important. What is super important? Round up to. Okay, it specifically tell us round up to. Round up to. So even this digit 1 is lower than 5, smaller than 5. It doesn't matter. You have to round up to 107. Okay. Yeah. Normal. If we follow the normal rounding rule, we should have a 106, right? But no, if we keep 106, we would not have enough. If we use the sample size 106, we would like a little bit short. We don't want to be short, right? Yeah, we want to have sufficient. So always round it up to the nearest whole number. So 107. Okay. The required sample size is 107. Would it be reasonable to sample this number of students? Yes, the number of IQ test scores is a fairly small number. Yeah, probably one college would be enough to have like 107 statistics class students. And to be honest, some of those questions, like a multiple choice question in the homework, not the best designed. Not the best designed. It is reasonable sample size. Would it be reasonable to sample this number? Yeah, 107, not bad. It's reasonable. All right, so this is the question. Any question about that? The formula will be given. The sample size necessary for confidence interval estimate of the population mean. Okay, then we move on to the next question. A data set includes 106 body temperatures. Well, that's the sample size, right? N equals 106. Body temperatures of healthy adult humans having a mean. So this is sample mean. Sample mean is given 98.7. And the standard deviation, excuse me, as sample standard deviation 0.66. Yeah, I like it to take notes when I read a question, symbolize the sentences, having a mean and standard deviation, construct a 99 confidence interval. So 1 minus alpha equals 99%, very high reliability. Estimate of the mean body temperature of all healthy humans. What does the sample suggest about the use of, or we'll do that later. Yeah, let's find the confidence interval, okay? Wow, this is about the mean. So T interval, remember that? Yeah. Let's go to stat and the tests. We're going to do a T interval estimate, number 8. Because sigma is unknown, because we're doing estimate the population mean. Yeah, student test, remember? Yeah, not test in this one. In this case, is an interval. T interval. We have the stats, so do not choose data. Yeah, highlight stats and confirm that. Then you would have the following entry needs to be taken care of. X bar, S sub X, N, C level, and calculate. X bar, where is it? Okay, 98.7. S sub X, 0.66. N equals 106. They're all given, right? Yes, C level is also given, 99%. But you don't enter 99%, you're going to enter a decimal, 0.99. Okay, let me enter those on my calculator. 98.7, 0.66, 106, 0.99. Calculate. All right, remember only enter one time. My calculator, if you double click and disappear, I have to find it, like go to the task stats and test again. Yeah, only enter once. I have this result, okay? I have the interval left inner point 98.532, comma, and right inner point of interval 98.868. Yeah, without the rounding. We round to 3 decimal places. Yeah, if we round, oh, it's already 3 decimal places. Yeah, 98.532, 98.868, exactly the same with the answer. Okay. What does this suggest about the use of 98.6 Fahrenheit as the mean body temperature? Well, let's see. Where does 98.6? It's kind of like a claim, right? Yeah, it's kind of like a claim. 98. If you claim 98.6 is the population mean, mean body temperature of the population, yeah, let's see what does your confidence interval estimate tell you about this claim. Yeah, 98.6 is in the interval, so not bad. So this suggests that the mean body temperature could be that. Yeah, could be that. A is, this suggests that the mean body temperature is lower than. B is higher than. No, it's inside the interval, so it could be, or positive B. We should choose C. All right, guys. Yeah, seems really is necessary to go over some questions from chapter 7 because it's been a while, right? The 2 chapters, one is confidence interval, the other is the test, hypothesis test. Recently, we have been talking about hypothesis test a lot. You would have to remember What's the confidence interval? How does that process work, right? Any question about this problem? Okay, no problem. Next, this one is so small. Let me make it bigger. Okay, use the pulse rates in beats. Oops. Yeah, when I try to zoom in, it here. Where did it go? This one. Use the pulse rates in beats per minute of a random sample of adult females listed in the data set. We have a data set. Oops. Available below to test the claim. Okay. Original claim. Mean is less than 73. 0.05. Okay, alpha is 0.05. And that's part A. So original claim is less than. So our null is mu equals. Our alternative is mu is less than 73. So this is a latitude test, right? Latitude test. You can see this is null, this is alternative. So we choose this one. Okay, that's the first part. Part 2, determine the test statistic and determine the p-value. This is actually pretty straightforward. The troublesome part is we need to enter the data set in the calculator. Well, you do it with me, okay? Yeah, let's do that. I know I really like to do that, but let's do it. How many of those? Okay, let's enter the data set. I'm going to enter that in L1, okay? In L1. Okay. All right, so let's go to stat, edit. I have something in L1. I'm gonna clear it, clean everything. Yeah. Okay, so 50. Yeah, I'm gonna be quiet for a while, all right? Everybody do the same. Enter those values in your calculator. Finally, half done. Continue. By the way, this is one list, not two. Okay, just to keep in the list one. Keep going. 88. Okay, finally. So how many values we enter? 38 value. So you should see that the calculator is waiting for you to enter the 39th value, right? Yeah, be very, very careful. If this step you mess up some number, even just tiny bit of error, you're not gonna get the problem right. Okay? Yeah. Okay, so that is L1. We have L1 ready. Yeah, all the data values in the first list. And then what do we do? We're gonna go to stat tests. And which function we are going to test? This is about population mu. So it's gonna be a t-test. 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 And you see data and stat, right? You're gonna highlight the data. Make sure not just blinking there. You have to confirm. Yeah. When you go down to the next row, you'll see the data is highlighted, is in a black background. All right. And the mu sub 0, 73. L1, yeah, it says L1 is already there. That's why I always enter the values in L1. Frequency is 1. And what tail test this is? Left tail. Yeah, left tail. So we highlight less than mu sub 0 and confirm and then calculate. And this is what I have, okay? This is what I have. I have mu less than 73. T equals negative point 0.025268103, and the p-value is 0.49107438885. And then x bar s of x. I'm not going to enter write that values because we don't really need it. The n is 38. Okay, let me know, do you have the same thing on your calculator? Suppose you enter those values correctly. All right, yeah, then your test statistic can be found here, T. How do we run it? Run it to 2 decimal places. So negative 0.03. What is it? Negative 0. Run it to 2 decimal places needed. Very different from the answer. What's the answer here? 0.88, negative 0.88. I might enter something wrong. Did I? My p-value is also different. P-value. Okay, let me double check my list, all right? There's a reason I don't like this type of question. We cannot use test that like a crunch. 73, 51, 53, 91, 56, 104, 62, 75, 63, 78, 77, 101. So the first column, nothing wrong, and then 88, 89, 58, 41, 87, 104, 61, 48, 40, 61, 48, 40, 82, 102, 93, I did not enter anything wrong. Oh, hold on. Oh, 90, oh, more. 98, 104, 79, 79, nothing wrong. And then let me double check the t-test. Some data 73, L1, left tail test. I still got the same thing. You guys have the same thing? Oh yeah, Kelly says same thing. But it's different from the answer though. Is this the correct answer? Negative 0.88.
Yes, that was the correct answer. I'm the one who sent this. I'm looking at the table and I'm wondering if maybe it got cut off. And maybe I failed to notice that even when I was entering it the original time too. Like if you look at the very bottom of the table for pulse rates, it looks like there might be some that are cut off.
Oh, okay. Where's cut off? You mean probably, oh, okay. You maybe miss one row, right?
One row or more.
Notice this.
Like it was not the entire screen, which that would have been my bad of, yeah. Thanks. But it does look like there's more numbers down below.
Look at that. Oh, okay. That makes sense now. But but I shown you the process, right? If I knew this, Kelly, I'll just.
Yeah, I've been able to do all those, all the other ones. I think just that one, I probably just didn't scroll down far enough.
Okay, guys. So if you have something like this in the test, oh, okay, yeah. So be careful. Yeah, that's also part of the test, right? Being careful. Yeah, very good, very good. Okay, then let me readjust the size. So the process the same thing. Okay, it's just make sure you enter the values correctly. Yeah, be patient. Yeah, I always give you enough time, so time is not an issue. Okay, so that's the last question. No, we have more from Kelly here. Okay, one more. The test statistic Z is obtained when testing the claim P. Let's see how many minutes we have. We have 13 minutes.
I'm okay with not doing this one if other people are. I sent it in, but we've done a whole bunch of ones like this.
Yeah, we done many of those. Yeah, how about let's skip it. And this one is fewer than 90% of adults. So original claim is P is less than 0.9. Have a cell phone in a reputable pool. Sample size. 81% said that. Okay, sample proportion. They have a cell phone. Find the value of the test statistic. Okay, this is about proportion. Yeah, so test statistic. Z is gonna be, what is the formula? Do I have the formula pasted here? Oh, okay, got it. Proportion. P hat minus P. Okay. P hat minus P. PQ over N. All right. So let's plug in the values. P hat 0.81, P 0.9, denominator P is 0.9, Q is complement 0.1 over 10989. Yeah. So this is just plugging in. Yeah, just plugging in. So this is what I do. Okay. You go to the main screen. I would do this. First, I use 0.81 to minus 0.9. I have the numerator negative 0.09. Yeah, now you are looking at a negative 0.09. And then divide that by square root second x squared. So now you are looking at the answers slash and the square root. Under the square root, I'm going to enter, yeah, because I know 0.9 times 0.1 is 0.09. 0.09 in numerator divided by the denominator 1089, and then move the indicator to the right outside the rule, and I got a negative 9.9. Do you have the same thing? Guys?
Yes, but how do you do that one in the calculator?
Oh, so what I did is I enter 0.81. Yeah, sorry.
No, sorry. Is it one of the stats tests, or is it you have to do this formula?
Oh no, you have to do the formula. You have to do the formula. Oh, I know what you're talking about. Let's see. Okay, I know what you're talking about. So let's see if we go to this is a proportion is a test. Oh, okay, original claim. So is the left tail. Yeah, we can go there. So let's go to stat tests, and then we're gonna do one proportion z test. One proportion z test. P sub 0 is 0.9. Oh, x. Yeah, you remind me. We don't have to do this. Yeah, we can use the function, right? Yeah, the number of success is n times p hat. Knowing you have to round the number to the nearest whole number if it's not, okay? Yeah, if we enter 0.81 multiplied by 1089, we have 882.09. So you're going to go up to round it to 882, round it down. Yeah, because 0.9 is lower than 5. So 882 for the x. Sample size is 1089. This is the left tail test. Yeah, we don't have to plug in the formula. I'm sorry. Yeah, you're going to get the z test statistic negative 9.909090. It's repeating, right? 909 repeating, and you rounded it to 2 decimal places. Oh, here there's a problem. If you use the calculator, if you use the function and you do this, and you round it to 2 decimal places, and your answer is supposed to be negative 9.91. You see what I'm talking about? But if you use the formula, you got exactly negative point. You got exactly negative 9.9. That's the difference. You know why? Because of this. Because you round the x. So I would say, in that case, probably use the formula can get a more accurate answer even just a little more accurate. Can you see the difference? It's just a little bit different, right? Because
yeah,
we round
that
it
makes sense. Thank you.
Yeah, no problem. Okay, so when I see something like that, when the x is not whole number, I would not round it. I would just use the formula. I get a better accuracy. But it took the 99.9 and counted it right, even when it set 2 decimal. Yeah. Because it's a negative 9.90. The 0, you don't have to enter that. Yeah, when you practice more in the system, yeah, you would like you know the pulse. How do you say that? You know the pulse of the system, right? You know the you know the standard, everything, convention, everything of the system. You would know how does the system work. Okay, but let's also ask some questions. Yeah, let's get this done. We have 5 minutes. The ages of a group of 141 randomly selected adult females have a standard deviation. So this is a sample size, sample standard deviation. So that will have a standard deviation 117.3. Assume that the ages of female statistics students have less than variation than ages of females in the general population. That makes sense because they are more similar, right? They are in the same school. Yeah. Population standard deviation for the sample size calculation. How many female statistics students' ages must be obtained? Okay, this is about the minimum sample size, isn't it? In order to estimate the mean age of all female statistics students, okay, the formula is, hold on. I think this is the formula. Confidence level, so 1 minus alpha equals 90%. Within half a year of the population mean. So our margin of error is half, or 0.5. Does it seem okay? Yeah, so it's very small. Yeah, read it as you can. This is about to find the minimum sample size. Yeah, find the sample size necessary to, of course, less the better, right? Yeah, the minimum sample size to estimate the population mean. Yeah, this is the formula. We did the one time earlier. So for every question about sample size, is this the formula? No. This is the formula for estimate the population mean. But if you estimate population's proportion, you use this formula. The one I handwrite, this one. Yeah, I also typed. Yeah, this is the formula to find the minimum sample size for confidence interval estimate of population proportion. Yeah, I have only those two, no more. Yeah, so for this question, I'm gonna skip a little bit. Yeah, just let's show you how do we find a z sub alpha over 2, okay? Anything else, just plug in and calculate. We start from 1 minus alpha, confidence level, and we get alpha 10% complement, and then divide by 2, 5%, and then subtract 5% from 1, find the complement of 5%, 95%. And we are going to use the 95% to find the z sub alpha over 2, okay? It is because the critical value is this is a 5%, and that means the green region, this region, is 95%. And what function we're gonna apply? We're gonna apply inverse normal function. All right, yeah. So let's go to calculator. Go to second verse. Inverse normal number 3. The area is gonna be 0.95. Yeah, the one in the box. Yeah, that's the area you're gonna enter. That's the only thing you need to take care of. And then I got a critical value. How do we run it? Oh, you know what? Don't run it, okay? Keep it as precise as possible. Yeah, I have this many digits. I'm gonna keep them. 1.64, 4, 8, 5, 3, 6, 2, 6. And you're gonna plug in that value here. Yeah, multiply by alpha 17.3 divided by e.5 and then raise the answer to the power of 2. And always round up the nearest whole number, as you see here. Round up to the nearest whole number. Yeah, we just had a very similar one. Yeah. All right, we ran out of time. Yeah, we finished everything. Oh, one more thing. Kelly found a question from the study guide, right? I didn't notice that there's a question to test the population standard deviation. It is beyond the scope. So we are not required to know that. You are not required to know that. So on the test, if you ever see something like that, write on a scratch paper and then email me. I will override that question. Yeah, for example, there's a 5 point for that question, and since it's it's not covered by our class, right? You can skip it, and then I can go to your grade book and then put a 5 there, and your score will not get affected. Am I clear about that, guys? In case you have something like that. Yes, yes.
Sounds great. Thank you.
Okay, awesome. Yeah, let me take a picture of the attendance one more time. So sad we're shrinking, our class size is shrinking. Okay, yeah, remote class is difficult. Communication. All right, okay, guys, good night. I'll see you on what day today? On Thursday. Yeah, waiting for my email about the tests. I think I probably already sent it or announcement. Have a good one. Bye bye.